Hello, hello. It is time to start Chapter 8. Chapter 8 is all about something called rational expressions and functions, which we're going to talk about today. Today we're going to specifically talk about multiplying and dividing rational expressions. This has a ton to do with factoring. So you need to remember all of your different ways to factor. If you don't, you should go back to your information from last semester and review. Any resources you have on factoring will be super, super important for this whole chapter. So the vocabulary you need to be on the lookout for is rational expression and complex fraction. So this is just a reminder about simplifying fractions, because basically a rational expression, you should fill this in on your notes, is a ratio or a fraction of two polynomial expressions like this, 1,700 over d minus 3. That's a rational expression. And when I simplify rational expressions, I'm basically simplifying fractions that have variables and polynomials. So just like when I reduce fractions, I reduce a rational expression by dividing the numerator and the denominator by the GCF. So for example, if I have the fraction 8 over 12, 8 is 2 times 4, 12 is 3 times 4. 4 is the greatest common factor. 4 divided by 4 is 1, so it reduces to 2/3. It is not okay to say, well, okay, 8 is 4 plus 4, and 12 is 4 plus 8, and then cross out these 4s. No, this is bad. Math crime, serious, serious math crime. In this case, I was crossing out terms. I'm not allowed to do that. I can't divide out a term because it's being added or subtracted. I'm only allowed to divide out factors, the greatest common factor in the numerator and denominator, and it has to be a factor of the whole numerator or the whole denominator. So if we look at this example here, this is a rational expression that has a quadratic expression in the numerator and the denominator. It would be wrong to just cross out the x squareds, because those are terms, not factors. They're being added and subtracted. So instead we have to factor first. In fact, our motto for this chapter is going to be factor first, always, always factor first. X squared minus 4x plus 3 factors into x minus 3 times x minus 1. And the denominator factors into x minus 5 times x minus 1. So now everything is factored. X minus 3 is a factor, x minus 5 is a factor, x minus 1, and x minus 1. So notice that all of the subtraction in this case is inside my parentheses, inside the things that are being multiplied, my factors. So I can divide now the numerator and denominator by x minus 1, and I'm left with this as my simplified fraction. So only cancel factors, not terms. Don't let this happen to you. Do not cross out terms. This is wrong, this is math crime, and you don't want to kill kittens. All right, so simplifying a rational expression, I always have to check and see first if it is factored. In this case, my expression is already factored. I have 3y times y plus 7 over y plus 7 times y squared minus 9. So all of my addition and subtraction is inside of my factors. Everything is being multiplied here. So I look for any common factors, and I notice that I have a y plus 7 in the numerator and the denominator that's being multiplied by everything else. So that y plus 7 divides out, and I'm left with 3y over y squared minus 9. That would be my simplified answer. So, taking the same expression, when would it be undefined? If you remember back in chapter 6 when we talked about functions, if I have the quotient of two functions, I always have to say, when is it undefined? So to do that, we need to make sure everything is completely factored. So here in my denominator, I have y plus 7, but notice that y squared minus 9 is the difference of perfect squares. So I can factor y squared minus 9 to be y minus 3 times y plus 3. So I basically ask myself, what numbers would I plug in that would make the denominator 0? That's where it would be undefined. So if I plug in a negative 7, I would get 0 times everything else. If I plug in positive 3, I would get 0 times everything else. And if I plug in negative 3, I would also get 0 times everything else. Any of those three values, negative 7, 3, and negative 3, make this expression undefined because they give me 0 in the denominator. So I want you guys to try simplifying this expression. Okay, your answer here should be B. Notice that this is already factored. So since x plus 5 and x plus 5 is a factor of the numerator and denominator, it divides out to 1 in both cases, and I'm left with x over x squared minus 16. And what would make it undefined? In this case, the answer is C. Remember that x squared minus 16 factors into x minus 4 times x plus 4, and I have to take all of those things into account. Even though the x plus 5 cancels, divides out to 1, negative 5 is still undefined for this expression. All right, so what happens if my original expression is not factored and I'm still asking for what values is it undefined? Well, in this case, remember I only need to check with the denominator to see where it's undefined. It's fine if the numerator is 0. It's not fine if the denominator is 0. So obviously I could try plugging in some values here, but the process that we're going to use is actually to factor. Remember I said our motto is factor first, always, always factor first. So this is our denominator right here, and I'm going to factor it. Two numbers that multiply to negative 15 and add up to negative 2, since my leading coefficient is 1. That's p minus 5 times p plus 3. So what would make those equal to 0? Well, positive 5 or negative 3. So if I plugged either of those values into the denominator, I would end up with 0. Let me go back and show you if it will let me go backwards. These were our options, right? So if I plugged in 5 or negative 3, then I would end up getting 0 in my denominator. But the key is to factor so that you can easily tell what values will give you 0. All right, you guys try the same thing for this one, please. All right, the answer here is D, negative 5 and negative 3. Okay, notice the topic here is to simplify using negative 1. So again, here I have some multiplication, right, but it's only inside of my different terms. My big operation here is basically subtraction. So I need to make sure that I completely factor before I do anything else. Factor first, always, always factor first. Remember, the first kind of factoring we always try is GCF. In this case, my numerator has a GCF of a to the 4th times the quantity of b minus 2, and my denominator has a GCF of a cubed times the quantity 2 minus b. Now you have to be careful because b minus 2 and 2 minus b are very close, but they're not exactly the same. Up here, my b is positive and my 2 is negative. In the denominator, my b is negative and my 2 is positive. So notice what they do. They rewrite b minus 2 as negative 1 times negative b plus 2. They factor out a negative 1 because then what happens? Negative b plus 2 is the same as 2 minus b. So I factor out that negative 1. And now I can cancel out my 2 minus b over 2 minus b. A to the 4th divided by a cubed is a, just like it's always been with our exponent rules. And I end up with negative 1 times a, or negative a, over 1, which is just negative a. So you guys try the same thing here, please, in this check your progress. All right, you should have gotten negative x. I'll show you the work here. There is the work for the factoring and how you would get to that answer. Okay, if you turn to the back page of your note guide, now we're going to talk about multiplying and dividing rational expressions. The nice thing about this is it basically goes right along with the simplifying that we did on the first page. And it's the same rules that it is for multiplying fractions. If I have a rational expression a over b and c over d, I just multiply across the numerator and across the denominator, and then I simplify. The same thing is true with dividing. It's the same process as with fractions. If I have a fraction divided by a fraction, I leave the first fraction the same, and basically I multiply by the reciprocal, so times d over c, and then I just multiply and simplify. So these are the same rules as we've always had for fractions. Okay, notice in this case, something you have to pay very, very, very close attention to is whether or not we're dealing with monomials or polynomials, things with more than one term. In this case, there is no addition and subtraction here, right? This is exactly like the things we did back in the exponent chapter where we're just simplifying. So I have 8 times x, 21 times y cubed, and so on. Every operation here is multiplication and division. So to multiply across the top, I just do 8x times 7y squared, which is 56xy squared. And basically what they did here is they wrote out all of the factors. Same thing in my denominator, they wrote out all of the factors and we canceled everything out. The way that I think of this when I look at it is I think, okay, I can divide the numerator by 8 and get 1. And I can divide the denominator by 8 and get 2. I can divide the numerator by 7 get 1, and I can divide the denominator by 7 and get 3. And then I have to be careful, of course, with my variables. Y squared over y cubed. The y is going to become 1 up here, and that leaves me with 1y in the denominator. Then x over x cubed, I divide by x, that gives me 1. I divide by x here, and that gives me x squared. So in the end, I end up with 1, because I canceled everything out in the numerator, divided out to 1, over 6 times x squared y. Okay, and if I'm going to divide, then I basically do the same thing. Notice here again I have monomials. There's no addition and subtraction, so I don't have to really do any factoring first. I rewrite it, I leave the first fraction the same, and I multiply by the reciprocal of the second fraction. And then I basically go back and do all of my dividing out again. So 10 over 5, that becomes 2 over 1, 6 over 3 becomes 2 over 1, and then I cancel out or divide out all of my different variables, and I'm left with 4k squared d over n to the 4th. So I've simplified as much as I can. Okay, we'll just do one of the check your progresses right now, so try this one. Okay, in this case, you should have gotten by over 2x squared. Again, there's no addition and subtraction here. I'm just multiplying and dividing monomials. So now move on to example 5, where I have polynomials in the numerator and in the denominator. So this is another case where we have to use our motto, factor first, always, always factor first. I cannot start dividing things out until I have factored. K minus 3 doesn't factor, neither does k plus 1, so we're treating those as one unit. Those are already factors by themselves. 1 minus k squared, that's the difference of perfect squares. It becomes 1 minus k times 1 plus k. And in the denominator, my leading coefficient is 1. This is a quadratic trinomial. So I'm looking for two numbers that multiply to 3 and add up to -4. So I end up with k minus 3 times k minus 1. Now look what we did here to cancel out. Here I have a k minus 3 in the denominator and the numerator, so I can divide that out to 1 in both cases. And then I have a 1 plus k. With addition, it doesn't matter, right? 1 plus k is the same as k plus 1. So that divides out to 1. Let me erase that so it doesn't get confusing. And then again, just like back in example 3, we have a 1 minus k and a k minus 1. So basically I factor a -1 out of the 1 minus k, and it becomes k minus 1. Then I can divide those out, and I'm just left with a -1. So that whole thing, that whole big fraction, multiplies and simplifies to -1. All right, if I'm dividing, before I do anything else, of course, I have to rewrite it, multiplying by the reciprocal of my second fraction of the divisor. And then I factor first, always, always factor first. 2 times d plus 6, I factored out the 2, the GCF. D squared plus 3d plus 2 is d plus 2 times d plus 1. My denominator, d squared plus d minus 2, factors into d plus 2 times d minus 1. And then d plus 3 can't factor, so it stays as its own factor. And they're just showing you here that they multiplied everything together into one fraction. And then they're dividing out the common factors. So I can divide out the d plus 3 and the d plus 2. And I'm left with 2 times d plus 1 over d minus 1. And it is fine to leave it in factored form. Okay, I want you guys to try this one. Multiply these two fractions together. Don't forget to factor first. All right, this one simplifies to 1. Let me show you the factoring. All right, here's the factoring. X plus 3 times x plus 2 over x plus 3 times x minus 3. And when I multiply, everything divides out. This is why it's really important to realize that when I divide something out, it's really dividing out to 1, because otherwise you might think this answer is just 0, but it's actually 1. And try this last one. The answer here is A.